Hi everyone, there'll be no starter today. We're going to get straight into going through the first 4 questions on the paper. Now if you've done everything, which is probably the best way to do it, then you can just go straight on to the next 4 and do it the next video and do the 3 videos together if you'd like. But it's not a bad idea to space it out because they are quite complicated. So I'm going to get straight into it, and I'm pleased this first question came up because I've tended to teach you to do this via substitution, but because on the very first question it says x has got to be bigger than 4, substitution won't work. So we'll get into that right now.
Right, so here's question 1, and as I said, substitution won't work as x can't equal 3 to make that bracket 0, 4 for that one, or -5 for that. We're going to have to use the second method, which is equating coefficients. So you get 1 mark if you just say that, looking at this, I always start from here and say, right, this is going to equal, if I was going to make this as a denominator, we're going to have to multiply. If we multiply this by both of these, a by 4 minus x and x plus 5, and add to that b multiplied by those two, and c multiplied by, well, we are multiplied by all 3 on the bottom, but those 2 as well, then that has multiplied out the denominator, and so all of this should be equal to the numerator on our original fraction. So it's 1 mark for saying that. Then you might have been confused, but not 2x minus 23. You might have been confused, but you get another mark if you expanded those 3 coefficients to give you this. So if you've got that with the things in whatever order inside, then you get a second mark. Then at this point you may have got a bit confused. Well, the next thing to do is expand all of those brackets, which should expand to all of this, and then you need to take out the different coefficients that we've got. So I've got minus ax squared, I've got plus bx squared, and I've got take cx squared, and that's going to give me my 4x squared. So from that I could say, well, I've got one positive, I could say that b take a take c is equal to 4. That's my first equation. I'm going to get 3 equations like this, then I'm going to do some simultaneous on it. I should then, for the x's, I've got minus ax, I've got plus 2b, and I've got plus 7c. So if I say 2b plus 7c, take just the 1a, is going to equal 1x. So for the x's I get that. I'm going to write that underneath here, 2b plus 7c take a equals 1. And then finally do the same thing just for the constants. So I've got 20a minus 15b minus 12c equals negative 23. So I can just write that one out, can't I? 20a plus 2b plus 7c is equal to negative 23. Now we've got to sort out the simultaneous equations having the 3 different things. So I'm going to take the simplest one, and then I'm going to get rid of b in it. So just in case you're not sure what I mean there, let's take that over there. I could say that therefore b equals 4 plus a plus c. And I'm going to substitute into both these equations here. So that one there is going to become, instead of 2b, I will have 2 with 4 plus a plus c instead of the b, plus 7c, take a equals 1. And for this one here, I'm going to have 20a plus 2 again times 4 plus a plus c. And have I done a mistake here? Yes, I have. That should be minus 12c there, shouldn't it? Minus 12c equals negative 23. And now it's just about being careful, and expand and simplify these should give you, sorry, I'm sure you spotted that I'd put 2b instead of minus 15b there for our constants when I made the equating coefficients one on that. So that, when you expand that bracket, should give you 20a minus 60 minus 15a minus 15c take 12c equals negative 23. Now what we need to do is simplify both of these equations, which should give you this. Now what I have done when I simplified that, I've added 60 to both sides to get the number over to there, and I have taken 8 from both sides, which is why I've got 1 take 8 is negative 7 there. And then this is just a fairly simple simultaneous equation. I'm going to multiply the bottom one by 3 to give me 3a plus 27c equals minus 21. And at this point you could use your calculator just to do your simultaneous equations, or if you add these together you get 8a is equal to 16. Therefore a equals 2. You can then substitute a equals 2 into here, and you will have 9c equals negative 7 take the a take 2 equals 9 minus 9. So therefore c equals negative 1. And then we can put our values of a and c being 2 and negative 1 back into, where was our nice simple equation? Somewhere up here. Oh yeah, this is it. B equals 4 plus a plus c. So b would equal 4 plus 2 take 1, which is 6 take 1 is 5. So our final answer is going to be a equals 2, b equals 5, and c equals negative 1. So that was a bit of a stinker to start things off with. And I'm sorry I got in a little bit of a mess there, but hopefully you can see the process that we've gone through. Let me know if you'd like a neater version. So question 2 is a remainder question. We've got a remainder here. So what this is saying is we need to divide this expression by x plus 6. So you get 1 mark just for setting up, making an attempt to do a division into that. Just setting up your long multiplication and gets you 1 mark. Then you divide the first term by x to give you x squared. Then you multiply x squared, x plus 6 by the x squared gives you x cubed plus 6x squared. Put a line under that. Take this from this. 6 from 8 is 2, so it's 2x squared. Then drop the x's down. We've got the minus 9x there. And we divide the x into the 2x squared, which gives us 2x. Times 2x by x gives you the 2x squared. 2x times 6 gives you 12x. Take this expression from that one. 12 from 9 is negative 21x. Drop the plus 12 down. divide negative 21x by x, and it gives you negative 21. So then we get minus 21 times x is that, 6 times 20 is 120, so that'll be minus 126. Remember, when you take a negative you add, so that will give us 138. So then if you say D equals 138, you're correct. And the rest of it here, ax squared plus bx plus c is equaling x squared plus 2x take 21. Therefore a is the coefficient of x squared, which is 1. B is the coefficient of 2x, which is 2. And c is the negative 21 there. But as long as you've got all of these values clearly found, if you've got that totally found and that all written like that, then you can have the 5 marks. So nicer question, that one. Moving on to question 3 then. And this one's not too nasty, you just need to remember that functions start next to the bracket and work out. So we need to show that this gets to this by starting off with PQX is going to be, you put X through Q and you get that, and then you need to treat all of this as X in function P. So your Q gives you 5 minus 2X, and that needs to be squared. And for the QPX goes through P, it comes out as x squared, so x squared needs to go in instead of x into here, so 5 minus 2, and I normally put a bracket there to show what it is that I'm putting in. Then you'll need to expand 5 take 2x to give you 25, negative 10x plus 4x squared. We've got our peanut there. So we can say that px has become 4x squared take 20x plus 25, and that's going to be equal to 5 take 2x squared. Add 2x squared to both sides and take 5 gives you 6x squared take 20x plus 20 equals 0. And that's nearly what we want there, isn't it? That everything is just doubled, so we can halve everything, and that gives us 3x squared take 10x plus 10 is equal to 0. All good so far, so that's all 4 marks for that part. Explain why it's got no solutions. You've got 2 routes you can take. The easiest one is using the discriminant, because remembering your ax squared plus bx plus c equals 0 form, the discriminant will always be if b squared take 4ac is smaller than 0, no real roots, because what we're talking about is a quadratic that's never going to cut the x-axis or the line y equals 0. So let's just pop that in. So b is negative 10, so negative 10 squared take 4 times 3 times 10 becomes 100, take 12 times 10 is 120, is negative 20, so you can say negative 20 is smaller than 0, so no real solutions. The other thing you could have done would have been to find the turning point, and you find the turning point by completing the square, and I did do that earlier on as well. That looks something like this, so your turning point would be at 5/3 and 65 ninths. So Either way, there's your 2 marks on that. Right, just one more question to go. All right, so question 4. The tricky thing here is you can't just, in order to find the inverse function, we normally, we say let g of x equal y, and then in order to find the inverse, we need to say, right, y is going to equal x squared, take 8x plus 7, and then we're going to need to rearrange to make x the subject of the formula. But the tricky thing here is you can factorize that into x minus 1, x minus 7, but that's not going to help you to isolate x on its own, because you're going to have 2 different x's which are difficult to sort out. So in this situation with a quadratic, that's when you need to complete the square, folks. So doing that, we can say half the coefficient of x, and then take that squared, and then we'll have plus 7 as well, being y. So then if we expand that, you should have x minus 4 squared, take 16 plus 7. So that in itself moves on to y equals x minus 4 squared, take 9. And now it's going to be a bit simpler because we can add 9 to both sides. And now we can do a square root. And it's not positive or negative, because with an inverse function, you could have come from one place. So we only ever use the positive. So that'll leave us with x minus 4. Then you just need to add 4 to both sides. And then finally, you need to just say that switch the x back in for the y. So you can say that the function, the inverse function, is going to equal x plus 9, the root of x plus 9 plus 4. And then to consider where you're coming from, where you're going to, if you look up here, the domain on the original is everything being bigger than 4. So when we go back the other way, that means the range of is going to be bigger than 4, or y is bigger than 4. They accept y is bigger than 4 is fine in the mark scheme, by the way. And then the domain takes a little bit more thinking about. What's going to give, if you have a value of x smaller than 9, then you're going to end up with this being worth less than 0. Now, as the range is bigger than 4, we can say that won't be 0 either. So we can say that x, the domain x, is going to be bigger than -9. So that this must be bigger than 0, so we can get a credible square root out of it. All right, and that's all for today. Tomorrow's lesson, I will go through the next 4 questions. So make sure, if you've only done the first 4 questions so far of the exam, that you do the next 4 before doing that. Really important to have a real go at doing everything you can on these before watching my solutions. All right, let me know if you had any problems with any of that. Cheerio.